Dear students, let's now explain the directive influence of halogens towards electrophilic substitution reaction. If halogens present in benzene ring, how the electrophilic substitution reaction is affected. Let us take a halogen, for example, chlorine atom. If chlorine atom present in benzene, how the benzene ring behave towards electrophilic substitution reaction. Here chlorine atom we know, when we compare electronegativity of chlorine and carbon, we know chlorine is more electronegative than carbon. So this shared pair of electrons will be more attracted towards chlorine atom through inductive effect, right? This effect is called inductive effect. Negative inductive effect. This effect acts in the upward direction. So due to negative inductive effect, chlorine is an electron withdrawing group. How is chlorine an electron withdrawing group? Due to negative inductive effect. Chlorine atom is more electronegative, so it withdraw the electron density, withdraw the electrons shared with this carbon towards it. Means from the benzene ring, electron is moved towards the chlorine atom through negative inductive effect. So this is electron withdrawing group. Now in addition to inductive effect, there is one more electron displacement effect due to the presence of chlorine atom, that is chlorine containing lone pair of electron. How many lone pair of electron? 3 lone pair. We know chlorine there are 7 valence electron, only one bond using one of the valence electron. So remaining 6 electrons are free, non-bonding. That means 3 lone pair electron. These lone pair electron present in chlorine atom, when attached to this benzene, which is a conjugated system, one of the lone pair can enter into the benzene ring through resonance. So there is resonance effect also. There is electron displacement due to resonance. Here the lone pair electron enter into conjugation with the pi electrons of benzene ring. One of the lone pair electron move towards the benzene carbon and form a new bond here. So this carbon atom become unstable. So the adjacent pi bond breaks and the pi electron move towards orthocarbon atom through resonance. This is called resonance effect. Positive resonance effect. Why positive resonance effect? Because here the movement of electron is from the chlorine atom towards the conjugate system, towards the benzene ring. The resonance effect is called positive resonance effect. Clear children? So in chlorine, if present in benzene ring, there are 2 electron displacement effects. One is negative inductive effect which act in the upward direction, right? The other one is resonance effect which act in the downward direction. Let this be the direction of resonance effect. This is the direction of resonance effect. Resonance effect act in the downward direction. Inductive effect act in the upward direction. So due to resonance effect, chlorine atom donate electron into the benzene ring. Electron move from the chlorine into the benzene ring. Due to negative inductive effect, chlorine withdraw the electron density from the benzene ring. So two opposing effects. The two effects act in the opposite direction. Here when we compare the magnitude of negative inductive effect and positive resonance effect of chlorine, the magnitude of negative inductive effect, the magnitude of the inductive effect is greater, or the inductive effect is stronger in chlorobenzene. In chlorobenzene, which is stronger inductive effect. The negative I effect of chlorine atom is stronger than the resonance effect. So what is the net movement of electron. Movement of electron is from the benzene ring towards the chlorine atom. So due to negative I effect, chlorine is electron withdrawing. This is due to negative inductive effect. Negative inductive effect. Chlorine withdraws the electron density from the. So the overall electron flow is from the benzene ring towards the chlorine atom. Because it is electron withdrawing, electron density of the benzene ring reduced. Electron density or electron richness of benzene is reduced due to the presence of chlorine atom. Chlorine atom is present in benzene. Electron richness or electron density of the benzene ring is reduced. So attack of electrophile becomes more difficult. Or we can say chlorine is deactivating, or chlorine deactivate the benzene ring. Deactivate the benzene ring towards the attack of electrophile. So this is a deactivating group. Chlorine if present in benzene ring, electrophilic attack is difficult. Or we say chlorine is a deactivating group due to its electron withdrawing nature, which is due to stronger negative inductive effect. Now here there is resonance effect also, that we need to explain a little more, which are all the resonance structures obtained. So through resonance, one of the non-pair electron present in the chlorine enter into conjugation with the benzene ring through resonance. So let us draw the resonance structures of benzene, of chlorobenzene. So this structure, one of the non-pair form a pi bond here, the adjacent pi electron break and pi electrons move towards the ortho carbon atom. So this structure is in resonance with it. Double headed arrow indicate resonance. Resonance with another chlorobenzene structure in which this pi bond breaks. The pi electrons are now on this carbon atom, ortho carbon atom. This ortho carbon atom is negative. Now here a new pi bond is formed with one of the lone pair electrons of chlorine. Now the chlorine contains only two lone pair, hence it is positive. Clear? The other two pi bond in the benzene ring, no change. See, this negative charge on the carbon atom is highly unstable. This is a carbanion. So this pair of electron will not remain here stationary. It will further move. The electrons will move from here and form a new pi bond here. If a new pi bond is formed here, this carbon atom becomes unstable. So this pi bond breaks and the pi electron move towards the para carbon atom. So we get another resonance structure for chlorobenzene, in which we can see the formation of a new pi bond here, and the pi electrons of this bond are now in the para carbon atom. So the para carbon atom is negative. The pi bond on the opposite side, no change. Then double bond chlorine, two lone pair, positive charge. Further, this two pi electron move from here to the adjacent carbon atom to form a new bond. So this carbon atom become highly unstable. So this pi bond break and the pi electron move towards the adjacent carbon atom. So we get another resonating structure in which a new pi bond is formed here. Here the pi bond breaks and now the pi electrons are on this carbon atom, which is also ortho, the other ortho position. This double bond, there is no change. Double bond Cl plus. Now further this pi electron move from the ortho position towards the carbon atom and form a new pi bond, so that this carbon atom become unstable. So the pi bond shifted back towards chlorine. That is a pair of electron which was originally present in the chlorine atom, through after conjugation with this benzene ring, as now going back towards chlorine itself. Means we get one more resonating structure in which here is the new pi bond, the other two pi bond remain there. This double bond becomes single bond. Chlorine gets its lone pair electrons back. So the charge is neutralized. No charge on chlorine now. So here also we get how many structures? 1, 2, structure 3, 4, 5. Here you can see structure 5 and structure 1 are equivalent structures. We get a last structure is similar to the first one. Only the position of the pi bond in benzene ring are different. Chlorobenzene is stabilized through resonance. There are 5 resonating structures. Clear? So there in the case of chlorine, when attached to benzene, there is resonance effect. Through resonance effect, one of the lone pair electron of the chlorine atom enter into the benzene ring through conjugation. So this one of the lone pair electron and the pi electrons of benzene ring are in conjugation, or we say are in resonance with one another. They are delocalized. Clear? See, if electrophilic substitution takes place in chlorobenzene, let us write the electrophilic substitution reaction in the case of chlorine atom, electrophile. Here, as a result of resonance in structures 2, 3 and 4. If you take structures 2, 3 and 4, you can see a negative charge on orthocarbonate. Here the para position, para carbon atom is negative. There is negative. Here also the ortho position there is negative charge. Right? So due to resonance, ortho and para positions are more electron rich due to negative charge. So this incoming electrophile, the chlorine atom will direct the coming electrophile to which position? The position which are more electron rich. Which are the more electron rich position? Ortho and para. Chlorine will say come and attack ortho, come and attack para. Because these positions are particularly negative due to resonance. In meta position there is no such negative charge. So compared to meta, ortho and para positions are more electron rich, electron seeking agent. It would preferably attack more electron rich ortho and para position. So here we get 2 products. One product is the one in which the electrophile is directed to the ortho position, ortho substituted product, and the other one is the compound in which electrophile is directed to para position. So we get ortho substituted product and a para substituted product. That means chlorine direct the incoming electrophile towards ortho and para directing. Towards the ortho and para position. That means chlorine atom is ortho para directing. Chlorine is ring deactivating group, but at the same time it is ortho para directing. Generally, deactivating groups are all meta-directing, like the nitro group. Nitro group is meta-directing. But chlorine is an exception. Chlorine or any halogens, they are deactivating group, but they are ortho-para-directing. Because when chlorine atom attached to benzene, ortho and para positions are more electron rich due to resonance. That is why chlorine atom is deactivating. The deactivating effect of chlorine is due to its negative inductive effect. Due to negative inductive effect, chlorine is an electron withdrawing group. It withdraws the electron density from the benzene. But at the same time, chlorine is ortho-para-directing group. Why it is ortho-para-directing group? This is due to resonance effect. Due to resonance, ortho and para positions are more electron rich compared to meta. So this is ortho-para-directing and deactivating. So chlorine is an exception.